Okay, so this is a key for topic 21, part C, worksheet 1. And on this worksheet, you have two parts. The first part is asking you to rewrite each of those quadratic functions that are in general form, and you want to write it in vertex form. Now, keep in mind that the work that you need to show is using completing the square. So you must complete the square in part 1 to get it to vertex form. So remember, vertex form is this. So for first of all, y equal ax squared plus bx plus c. That is general form, right? And you want to rewrite this in vertex form. So we're going to write it as a times x minus h squared plus k. So that is vertex form. All right, and we're going to do that by completing the square. So that's part 1. So let's get number 1. So number 1, you have f of x equal x squared minus 10x plus 2. All right, so first thing you're going to do is you're going to bring this constant to the other side. Now, also keep in mind as we go through the others that the coefficient of x squared must be 1. Okay, so in this case, the coefficient of x squared is 1. So the next thing you got to do is bring this constant to the other side. So we have f of x minus 2 equal x squared minus 10x. And now what you're going to do is you're going to now complete the square on the x terms. And so you've done that with circles, so now you're going to do it with quadratic functions. And so if I complete the square, I'm just covering this part up. If I complete the square on the x terms, remember, this has to be a coefficient of 1, and it is. You're going to take the coefficient of x, which is negative 10, you always divide by 2. And when I divide by 2, I get negative 5. Once I get that negative 5, I square it. And now I get 25. So whenever you square that number, this is always a perfect square. So hence the idea of completing the square. You're going to rewrite it as a perfect square trinomial. So it's always a perfect square because you're squaring it. Okay, now once you do that, you're now going to add 25 to the right-hand side. But remember, this is an equation. See the equal sign? So what you do to the right-hand side, you also have to do to the other side. Okay? Now, let's go ahead and combine like terms here. So I get f of x plus 23 equal. Now, this trinomial should now be a perfect square trinomial, which means that you can now factor it as a binomial squared. And so when you do that, you get x minus 5 squared. So x minus 5 times x minus 5 is this. And now I want you to notice, see that negative 5 here? That's that negative 5 you see. And now you get f of x by itself. So now you're going to subtract 23 from both sides. And there's your answer. So f of x equals x minus 5 squared minus 23. So there's your vertex form. So for number 1, the answer is, so the works on the next is on another page, but here's your vertex form. So this is f of x. You must say f of x. So f of x equal x minus 5 squared minus 23. Okay? All right, so let's look at number 2. Number 2, we have this for number 2. We have g of x is equal to 2x squared plus 12x minus 3. Now, the way I'm going to do that, first of all, notice that x squared does not have a coefficient of 1. The coefficient of x squared is 2. Whenever you complete the square, whenever you are completing the square, the coefficient of x squared must be 1. So what I'm going to do at this point is I'm just going to go ahead and divide both sides by 2. All right, so if I divide both sides by 2, I divide both sides by 2. I'm going to rewrite it. All right, and remember, if you go back to the lessons, another way you could have done it was to go ahead and factor out a 2. But some students have some issues with factoring out a 2 and then going from there. But that is another approach, and I'm gonna go ahead and do it both ways just to show you. But one way we did in our lesson was we went ahead and we divided both sides by 2, just like this. okay? And so I get g of x divided by 2 equal 2x squared divided by 2 is x squared. 12x divided by 2 is 6x, right? That's an x. And then we have negative 3 divided by 2, just like that. Now remember, just like with this one, I brought the constant to the other side. So let's bring this negative 3 halves to the other side. So I'm going to add 3 halves to both sides. When I do that, I get this plus this. So I have g of x divided by 2 plus 3 halves equals, and this is 0 here, and you get x squared plus 6x. And we're almost done. So now you're going to complete the square on the x's. So I take the, see this now a 1 here. So I take the coefficient of x, which is 6, I divide by 2, and I get 3. Now what I'm going to do to this 3 is I'm going to square it, I'm going to get a 9, and that's what you're going to add to both sides. So here, so you're going to say plus 9, plus 9. All right, now here's what you're going to do. Now listen carefully, you're going to need your calculator also. So you have g of x divided by 2. All right, now let's go ahead and combine these like terms. Now, you really don't need your calculator for that, right? Because you know that this is 1.5. You know that this is 9. So together, in that 10.5, and 10.5 is 21 divided by 2, okay? But if you need to use your calculator, use your calculator. So you're going to say 3 divided by 2. Remember, you got to make sure you know how to use your calculator. Plus 9 equals 10.5. And all of you know that you see that 10.5, so 10 and 5/10, so that's 5/10, which is 1/2, right? So 10 and 1/2, and then just change it back to a improper fraction, you get 21 over 2. But if you use your calculator, you're going to say second PRB, you're going to press equal, and there's you get 10.5. You just got to convert that back to a improper fraction. And this should now be a perfect square trinomial, and it is. You get x plus 3 squared. And then all you do is bring this 21 halves to the other side, just like that, and you get g of x divided by 2 equals x plus 3 squared minus 21 halves. All right, now listen carefully though. See, you got to get g of x by itself. So right now you're dividing by 2. So now what you're going to do, and I ran out of room, so let's go ahead and do it this way. So since I'm running out of room here, I'm just going to do it this way. So you're going to multiply both sides by 2. So times 2. Now be careful over here. See, there are two things, right? And in our lessons, we talked about that. So you have this part that's being squared, and you have your constant right here. So the part being squared and the constant. Now, okay? So both of those, 1, 2, have to be multiplied by 2. So keep that in mind. So put that like in brackets right now, and then we're going to distribute. So this becomes, the 2's divide out. So I get g of x is equal to 2 times x plus 3 squared. And then notice 2 times a negative 21 halves. So 2 times a negative 21 halves. The 2's divide out, you're left with negative 21. So this becomes minus 21. And there's your answer. Okay, so that's one way. Now I'm going to do the other way as well, just to remind you. But so this is g of x equal 2 times x plus 3 squared minus 21. Okay, so let's look at the other way for doing number 2. So here's what I mean by the other way. So we have g of x is equal to 2x squared plus 12x minus 3, okay? And so remember, when we did this one, before we complete the square, we had to get x squared to have a coefficient of 1. So one way was to divide by 2. The other way is to factor out a 2 from the x terms. But let's go ahead and first bring the 3 to the other side. So g of x equal, oops, sorry, I'm going to add 3 to both sides just like this. So I have g of x plus 3 equals 2x squared plus 12x, okay? Now I'm going to factor out a 2 from here. So I'm going to get g of x plus 3 equal 2 times, x squared plus 6x. All right? Now be careful. So cover up that 2 so you don't get confused. So now we're going to complete the square on the x's the same way. See, that's just x squared plus 6x, right? The same way you did this one, 6x squared plus 6x. All right? Now, so you complete the square on the x's. So we're going to take half of 6, which is 3, and we're going to square 3, which is 9. You're going to add 9. Now be careful. Remember when we did this? We had 9 right here, right? So we added 9 to both sides. Correct? You got to be careful here. Be careful here. You are going to add 9 here, but remember, you don't add 9 here because remember that 9 is being multiplied by this 2. So even though you're saying I'm adding 9 here, that's not really adding 9 to the right side. You're adding 18 to the right side, which means you have to add 18 here. Okay? So you got to be careful. And so now we get g of x plus, and then 18 plus 3 is 21. Hence, see that 21, right? That 21 right here. Equal 2 times, and this is now a perfect square trinomial, so that's x plus 3 squared. And all you do is subtract 21 from both sides, and there's your answer. So g of x equal 2 times x plus 3 squared minus 21. So doing it this way kind of saved you a lot of fractions, right? But you got to be careful because there are some problems where factoring it out could be an issue as well. It wasn't here. It was not here because that coefficient of x was divisible by 2. That's why. Okay, so does not matter which approach you take. It helps to know both because that way if you get stuck here, then you have an alternative. If you get stuck here, then you have an alternative. Okay? All right, so that was number 2. All right, let's look at number 3. Number 3, we have this function in number 3, and we're going to do it both ways as well. All right, so here's number 3. You have h of x equal negative 3x squared plus 24x plus 8. Okay, so I want to rewrite this in vertex form. So the first approach, let's go ahead and divide everything by negative 3. So notice that this coefficient of x squared is not 1, so I got to get it to be 1 before I can go ahead and complete the square. So let's go ahead and divide by negative 3. So let me go ahead and rewrite it over. Okay, so divide by negative 3, just like this. Okay. All right. Now we have h of x divided by negative 3. Just rewriting this over equal. Now look, see this is what we have here is I'm going to just write it 3x squared divided by negative 3 plus 24x divided by negative 3 plus 8 divided by negative 3, right? So you're dividing each of these terms by negative 3. Then we're going to simplify as much as this part as possible. So h of x divided by negative 3 equal negative 3 divided by negative 3 is 1. So I get x squared. 24 divided by negative 3 is a negative 8. So I get negative 8x. And then this a positive divided by negative is a negative. Okay. Now I'm going to add 8/3 to both sides. So bring the constant to the other side. So I get this plus this. So I get h of x divided by negative 3 plus 8/3 equals, this is 0, x squared minus 8x. Now I'm going to complete the square on the x's. So I'm going to complete the square on the x's. So when I'm going to cover this part up. So I take half the coefficient of x. So the coefficient of x is a negative 8. Take half of it, you get negative 4. I'm now going to square negative 4 and I get a positive 16. So I'm going to add 16 to both sides. Okay? Now, so I get h of x divided by negative 3. Okay, now let's go ahead and combine these using a calculator. So I get 8/3, so 8 divided by 3, plus 16, right? Plus 16 equals this. Now, all of you know that this decimal part, 0.666 repeating, that is 2/3. So this is 18 and 2/3, right? So I'm just going to write it right here. So that is just to show you that is 18 and 2/3. So 3 times 18, if you can't do it in your head, then you just do that. Just be careful. That's 54, and then 54 plus 2 is 56. So this is 56/3. So that's what this is. So this is h of x divided by -3 plus 56/3. Okay? Now, if you did not know, that 8/3 plus 16, when you did that, if you did not know that that was 2/3, then just use your calculator. So second PRB, press equal, and notice 18 and 2/3. And you just convert that back to an improper fraction. If you don't have a calculator, just remind ourselves how to do this. So if you have a calculator, you have to say 8/3 plus 16 divided by 1, right? The LCD is 3, so you're going to write 2 equivalent fractions with that denominator 3. So these denominators are already the same, so 8/3 is equivalent to itself. 16 is equivalent to what fraction with a denominator 3? Well, you're going to have to multiply both numerator and denominator by 3. And so 16 times 3, if you use your calculator, 16 times 3, you get 48, right? And then 48 48/3 plus 8/3 gives us 56/3, which is what we saw here. And that's how you do it by hand, right? So now I get this equal, and this should now be a perfect, oops, I messed up there. That should not be, 16, I forgot to put 16. All right, that's 16. So this should now be a perfect square trinomial. And so when I factor, that'll be x minus 4 squared. All right, now let's bring this back to this side. So h of x divided by -3 equals, so I'm going to subtract 56/3 from both sides, right? So I get x minus 4 squared minus 56/3. And then we got to get h of x by itself. So right now I'm multiplying by -3. The opposite is to, I'm dividing by -3. The opposite is to multiply by -3. But remember, these two parts have to be multiplied by -3. Okay? So now I get this. So I get h of x equal -3 times x minus 4 squared. All right, now be careful. See, that's a -3 times a -56/3, right? A negative times a negative is a positive. The 3's divide out, and you get a positive 56. And so there's your answer. Okay, so let me go and write it out first. So h of x is -3 times x minus 4 squared plus 56. Okay, now notice how much work that was. That was quite a bit of work, right? And then many students freak out when they see all those fractions. You could have, instead of dividing both sides by this coefficient, you could have factored out a -3 because this 24 is divisible by 3. So let's go ahead and do it that way as well. All right, so let's go ahead and do it that other way. So I'm going to go ahead and rewrite this over just to show you. All right, now, so here's your steps. So now what you're going to do is you're going to subtract 8 from both sides. So I get h of x minus 8 equals -3x squared plus 24x. Now you're going to factor out a -3 from here because you got to get this x squared to have a coefficient of 1. So I got h of x minus 8 equals -3 times, now be careful, -3 times x squared is a -3x squared. -3 times a -6x, 8x, -8x is a positive 24x, okay? All right, so now we're going to complete the square, cover this part up now. We're going to complete squaring the x's. So I take half of -8, which is -4. I square -4, and I get 16. Now be careful, don't add 16 to both sides because you're not really adding 16 to this side here. You're adding -3 times a positive 16, okay? So you're really adding a -48 here. So I'm adding a -48. I'm going to add a -48. So you got to be careful when you're doing the factoring, when you factor out, because it's not just adding 16. you're technically adding negative 3 times 16 on this side, and you have to do the same thing here. So this becomes h of x minus 56 equals a negative 3, and this should now be a perfect square trinomial, and it is x minus 4 squared. And then all you got to do now is add 56 to both sides, and you're done. H of x equal negative 3 times x minus 4 squared plus 56. Okay? So in this case, since the coefficient of the x was divisible by negative 3, and over here, since the coefficient of x12 was divisible by 2, it is easier to go ahead and factor out. But the mistake that students forget about, the issue that students forget about is that when they get to that point, they tend to add 9 to both sides, which is not correct, because this is 9 times 2. So you're really adding 18 to both sides. Okay? All right, so that was number 3. Okay, now let's look at part 2. Now, part 2, it says this: use the shortcut presented in the lesson to rewrite each quadratic function from general form to standard form. And in that lesson, basically you were using the vertex formula. So you had to use the vertex formula. And that's all I wanted you to do. So if you looked at the lesson, this is what you would have seen. Okay? So let's go ahead and look at that one. So this would be number 4. So number 4, we have f of x equal 5x squared plus 10x minus 4. And remember the vertex formula is this. It's negative b divided by 2a, comma, and then f of negative b divided by 2a. And so a in this case is 5 and b is 10. So a is 5 and b is 10. And so remember, a is the coefficient of x squared and b is the coefficient of x. And so the x-coordinate of the vertex is going to be negative b divided by 2a. And if b is 10, then the opposite of 10 is a negative 10. 2 times a is 5. So I get negative 10 divided by 10, which is a negative 1. Okay? So my vertex, the vertex so far is negative 1 for the x-coordinate. To find the y-coordinate, remember you're going to substitute negative 1 into your function where we see the variable x. So the y-coordinate is f of negative 1. So that becomes 5 times negative 1 squared plus 10 times negative 1 minus 4. So negative 1 squared is 1. 1 times 5 is 5. 10 times negative 1 is a negative 10 minus 4. So this becomes a negative 5 minus 4, which is a negative 9. So my vertex is negative 1, negative 9. Okay? Now, once you get that, notice, you can go ahead and write it right here. Once you get that, so remember your vertex is negative 1, negative 9. So remember, that means this is h and this is k. So remember your vertex, now you want to write this in vertex form. So remember vertex form is y equal a times x minus h squared plus k. So now you know h, you know k, you know a. Remember, a is the coefficient of x squared. You found a. A is 5. All right, so your answer, you're going to say f of x. So f of x equal a, which is 5, times x minus h, which is negative 1 squared, plus k, which is negative 9. Don't leave your answer like this, because I expect you to know how to rewrite this idea and this idea. So your answer, you're going to say f of x equal 5 times x plus 1 squared. X subtract the negative 1 is x plus 1. Adding a negative 9 means the same thing as subtracting 9. And there's your answer. All right, so that's the shortcut I referred to in the lesson, using the vertex formula. So the answer for that one will be f of x equal 5 times x plus 1 squared minus 9. Okay, let's look at number 5. So number 5, you have this for number 5. Okay, so here's number 5. you have g of x equal negative 6x squared plus 24x plus 3. All right, and so you want to rewrite this in vertex form using a shortcut, so using the vertex formula. So the vertex formula, remember, is negative b divided by 2a, comma, in this case it's g, so you can say g of negative b divided by 2a. All right, and so a in this case is a negative 6, and b is a positive 24. And so the x-coordinate of the vertex is negative b divided by 2a. If b is 24, then the opposite of 24 is a negative 24. Divided by 2 times a is negative 6. So I get a negative 24 divided by negative 12, which is a positive 2. So I found the x-coordinate of the vertex. I found h, because it's basically h. The y-coordinate will be, so now to find the y-coordinate, which is g of x, in place of x, you're going to substitute 2. So we're going to find g of 2, which becomes negative 6 times 2 squared plus 24 times 2 plus 3. So order of operations, you're going to square first before you multiply. 2 times 2 is 4. 4 times negative 6 is negative 24. 24 times 2 is 48 plus 3. Negative 24 plus 48 is a positive 24, and 24 plus 3 is 27. So the vertex is xy, so 227. Now remember, you want to rewrite this in vertex form. So here's vertex form. So vertex form is y equals a times x minus h squared plus k. So you got to find h and k. So this is your h and this is your k, because that's your vertex. And then a is a coefficient of x squared, which you found to be negative 6, right? So a is negative 6. So I get g of x is equal to negative 6 times x minus h is 2, squared, plus k, which is 27. And that's all you can do. There's your answer. All right, so in number 5, you can say g of x will equal negative 6 times x minus 2 squared plus 27. Okay, so that is the key to worksheet 1 for topic 24, part C.